Welcome to PCB Chat, where we talk with experts across the printed circuit design, manufacturing, and electronic supply chain fields. I'm Mike Buteau, president of the PCEA. Today, we welcome back Madan Jagernauth, marketing director and project facilitator of the High Density Packaging User Group Consortium. Regular listeners will know HDP as the long-standing nonprofit consortium, they turned 30 last year, of electronics manufacturers and suppliers that work collaboratively on various technical problems in order to reduce cost and time to market. Madan will discuss some of the projects HDP has underway, many of which are due to be completed this year. He will also touch on a few papers that HDP recently prepared, two of which won awards for the respective conferences where they were, or in one case, will be presented. Welcome back to PCB Chat, Madan.
Thank you, Mike. Good morning. How are you today?
I'm great. Thanks. It seems like 2024 is something of a transition year for HDP. You had your 30-year anniversary last year, so now that's behind you. You completed 8 projects, and you have 18 more projects now in the implementation phase. We can do this many ways, I suppose, but let's start with the year just ended. As part of your anniversary, HDP prepared 4 special retrospective reports. Can you summarize them for our listeners and explain why HDP felt it was important to look backward as well as forward?
Well, Mike, 30 years is a long time for a consortium like this to be operating. So it was important for us to take a look back to see where we've come from and where we're going. There are lots of challenges in the industry. A couple of years ago, we had taken a good look at the technical direction in the industry and the kinds of things that HDP should be working on and our members should be paying attention to as the industry evolves. So, looking back was just trying to get the sense of where we've come from. So in the first decade, it was a small group, about 15 members on average. So there are a small number of things that could be done. About 20 years ago, with the transition to more environmentally friendly materials, lead-free solders, for example, HDP became more important to members and grew up over the second decade from the 15 to where we are now, about 50 members. And did some really good work starting about 20 years ago in lead-free solders. Some very seminal work being done on SAC 305 in the early days, SAC 405, writing implementation guides and those kinds of things. So that was the first thing I looked at was what did we do on lead-free solder assessments over the years? And there were some very important set of projects that were done, reports written, and used by our members over time. Related to that is at the time that lead-free solders came onto the scene, there were no materials for printed circuit boards that were really reliable. So the evaluation of laminate materials became very important to say which one of these things would actually work with these higher temperature solders, because the reflow temperatures for lead-free solders are much higher than the reflow temperature for a eutectic tin lead. So starting about 2006, HDP has been running material evaluations for laminates, and we're in our 7th phase now. So that's the second part of looking back at what material testing we did over time. And then, of course, there's all of the other associated technologies that evolve over time for printed circuit boards themselves, with micro vias and higher density vias and those kinds of things, stacked vias, whatever they are, and the assembly technologies of how you actually put components on boards. So those are the 4 legs that I looked at as I was taking the retrospective. And then relating that now to how we go forward with our technical direction on the next generation of high-speed materials and evaluating those, the next generation of solders and evaluating those, higher copper densities and what's coming next with higher copper densities. And with all of this change, what changes are needed to the reliability assessment methodology as you get to things like higher voltages on printed circuit boards for electric vehicles or other types of applications. So it all relates back to where we've come from, where we are today, and where we're going.
Now, I know that HDP keeps its reports generally in-house. They're done by the members for the benefit of the members. Was there any thought given to making the retrospective reports available to a wider audience?
Yes, those are actually available on our website. So, I published a couple of them through LinkedIn. They are available on the website. They basically say what we have done. They don't cover the results of what we've achieved. Okay, so it's more. So I'm a marketing guy. It's more of a marketing thing than a.
Okay, well, thanks for that perspective. Now let's talk about the recently completed projects. What highlights can you share about those?
There's a lot of work going on things like microvia reliability, the way boards stack up, and the flatness of boards. New technologies like photonic soldering. So there's a variety of projects that got done last year. We completed 8 projects last year. We have 18, like I said, in implementation right now. And when you look at it, there are 6 projects related to materials, primarily high-speed materials. There are 4 projects related to solders. 2 of them are related to the reliability of solders themselves, and 2 of them are to the application of these solders with reflow reliability and with rework reliability. There are 4 projects related to higher copper densities for back drill, one of them, one with microvias, and 2 of them with inner layer copper balancing. And then there are 2 or 3 projects related to different test methodology, like next generation surface insulation resistance testing, one on copper roughness. And so there are a variety of things. And when I look at the 4 or 5 legs of our technical direction and the fit of the projects to the technical direction, about 2/3 of our projects are in line with where we see the technical direction the industry pointing. There are, of course, some projects that members have very specific near-term issues they're trying to address, and they have commonality with other members, so those get in the mix as well.
HDP has 23 projects underway. And as I mentioned in our opener, 18 are in the implementation phase. These projects are approved by the HDP Board of Directors and going forward are restricted to HDP members and select others that have signed the R&D participation agreements. So implementation really is where the rubber hits the road, so to speak. We can't go through all of them, of course. And you mentioned a couple that were recently completed, but you do have a few in areas that are constantly evolving, like high-speed materials and next-generation solder alloys. So what can you tell us about those?
So we're in the 7th phase of our materials evaluations right now. Let's start in 2006. That's phase 7 is now. Through phase 6, we completed evaluations of 85 different laminate materials. Phase 7 is testing 11 more materials. And this tends to be like a 2-year project. There's a completion date that was set it was launched last year. The completion date was set for 2025 because the guys who are running this know that to do a complete set of testing on this set of materials takes a good long time, right? So these are major projects that require a lot of member participation and a lot of very detailed testing. What was done for that as well is that the test vehicle that was used previously was updated to include some new test coupons. So that's very important for our laminate material suppliers, our fabricators, and our OEMs. Right? Everybody in the chain is very interested in that project, and usually that project gets the highest participation amongst members because it is of such a foundational creates such foundational knowledge for our membership. 2 others I'll mention. and these relate to the papers as well, is the solder evaluation. We have been evaluating third generation solders for about 8 years now. I think the eval one for third generation started in 2016 and was completed around 2019, 2020. And this is a collaboration we're doing with INEMI. In the first phase of this evaluation, the thermal cycling was done with 10-minute dwell times at the two extremes, and three different thermal cycles. There was also some drop testing done to see if that kind of not drop testing, vibration testing, to see if that kind of a test would actually affect the reliability of the solder. So that was done 3-4 years ago, completed. The second phase started then, and the focus was looking at some of these solders have to operate for extended durations at high temperature. So there was a desire to test for a longer dwell time. So instead of 10 minutes at the extremes, it was increased to 60 minutes at the extremes. So, adding essentially 100 minutes per thermal cycle to this process. These are very reliable solders. You add 100 minutes to a cycle, it takes it to a much longer cycle. It's even more boring than watching a pot boil. It's like watching grass grow. But the good news about it is the solders are very reliable. So we're in the middle of that right now. And then there is a third phase of this that's running in parallel that is looking at saying, well, there's a traditional way of thermal cycling that limits the rise time of the cycle. If we did a shock test, would that change the reliability of the material? Would we have the same failure mechanisms? And could we substitute a faster rise time to complete this kind of evaluation faster? So that's running in parallel. So this is a big part of providing information to our members on how the third generation of solders. Some people are still specifying tin lead. What we're seeing is this current generation of solders are very reliable, but when the testing is done, I'm sure we'll get done at some point. We'll see what the results really are that can be published and things like that. The intent, of course, with something like this, as big as it is to publish as much as we can.
How is it decided which materials are included? Does it require participation by the material supplier?
Yeah, I mean, everything like this is when we launch a project, we will notify all of our members and invite them to participate in the project. And the ones who want their materials to be part of it, in terms of the solders, will say, yeah, if they'll provide the materials and which one of their solder compounds they want to provide. In the case of Eval 3, there was a desire to run a smaller set so that we didn't have as big a matrix. So there were a subset of the ones from the second phase of evaluation that went into the third phase of the evaluation. And then, of course, it's a question of which of our laminate suppliers would participate in providing materials for the test vehicle fabrication and which one of our fabricators would fabricate. In this case, the project is being led by Richard Coy from Nokia. Panasonic provided the laminate materials, and Sanmina built the test vehicles. And then there are the usual set of members: Shenzhou, Nihon Superior, Indium, McDermott provided solders. Right? I may be forgetting one or two. So,
got it. I want to mention the sponsor of today's podcast is PCB East, the electronic industry's East Coast Conference and Trade Show. Coming in June to the Boston suburbs, this year's event features more than 75 hours of in-depth electronics engineering training, plus a special all-day forum on Ultra HDI design and manufacturing. And attendees for the free expo will see more than 60 leading suppliers of printed circuit design software, materials, in fabrication and assembly equipment and services. Visit PCBeast.com for more information. Speaking of conferences, HDP won a couple Best Paper Awards of late, one in the area of fabrication and one in assembly. I think nothing better shows the breadth of HDP's research.
So our members are doing really good work, Mike. So I talked just now about the solder projects and the VAL Phase 2. Paper was presented by Richard at SMTAI last October, titled A Collaborative Consortium Project to Assess the Effect of Thermal Cycling Dwell Time on the Reliability of High-Performance Solder Alloys. So this is the one that we're doing the 60-minute dwell time on. This is a collaboration between HDP and Dynami. Testing is being done by Nokia, Collins, and CALS for this particular phase of the project. So it's a big effort across a large number of industry participants who are very interested in the results of this type of testing. And all Richard presented really was a status update on where this project is. I came into HDP about 3 years ago and took over this project 3 years ago. I forget when I came in. And have been working with as a facilitator on this project for that period. And we are still in the middle of testing. Not all of the testing is done. The test vehicle is very interesting. It's got two components on it, a 192 BGA and an 84 BGA. And as you'd expect, in 192 BGA that's larger fails first, and the 84 BGA device, sometimes it takes forever, especially with the 0 to 100 Celsius cycle, takes forever to fail.
I really think that this underscores the importance of HDP as a collaborative organization. There is no other organization I can think of that is doing this type of broad-based research with this many members and consistently producing results, right? So, HDP, if I go back 30 years, I think most people thought of HDP as being a board interconnect organization. As I look over, what your research has been over the last several years, nothing could be further from the truth. It really is very broad-based, and you're filling a gap that is badly needed.
Well, I think what members see is that they can run projects through HDP that they are not able to run themselves efficiently inside of their companies, either because it will take too long to do, or they don't have the right set of resources all within the four walls, right? Like when you look at a project like that one, from the material suppliers all the way to the fabricators and the test houses, and then you look at the next one, the ones that will be presented at IPC Apex, those papers that are basically another reflection of what we're doing. The paper that won Best of Conference, Best Paper Award includes device sizes from 26 square to 100 square millimeters, right? 26 by 26 to 100 by 100. 8 different laminate materials, 8 fabricators that made these test vehicles. Right? Looked at the surface topology variations as you look at packet size changes, the way copper is distributed on the various layers, the resin fill rates, because if you have a high flow versus a low flow resin, it'll change. What happens in ground planes versus via fields. And then how do you get to a point of designing something like this where you can actually balance the in-layer copper to get the flatness you need to assemble large BGA devices? Right? This is of high interest to many people as you look at larger integrated circuits being put on print circuit boards, and the boards are getting thicker because you're going to higher speed devices, more I/O in the boards. All of this is interrelated. So you've got what I would say is a highly stochastic system that you're trying to control. Right? So there are many variables in there. I don't know that you can control all of them at any given time. So there's always going to be some variability, but it's how do you manage it as you gain more knowledge about what you can do in the design to get the results you want. So this is one that was written by Gary Brist and Neil Hubble. Gary is with Intel. Neil is at Acrometrics. This is where the interest is right now.
Have your members come to you and asked about starting a project in artificial intelligence?
No, but I mean, what's artificial intelligence, right?
Me.
Seriously, there are three elements in networks, right? There's the compute part, there's the storage part, and there's the transmission part, networking, right? Networks are getting faster. The next generation of wireless and optical networks are running at very high speeds. The 1.6 terabit per second network is going to require baud rates of 112 gigabaud. The next generation wireless networks, they're talking about sub-terahertz spectrum from 90 to 300 gigahertz. Try doing that on a printed circuit board. This is where the interest is. So, one of the projects we have running right now is looking at surface treatments and the effect the surface treatments have on high frequency, and that will be tested up to 120 gigahertz, I believe. Because as you get to those speeds, you're talking about some major skin effects. And when you've got an immersion gold or whatever else on top of the copper, where does current actually run? Does this layer of surface treatment affect the performance of that circuit? So there are things like that are being done right now.
Now, most of your biannual meetings take place in the U.S., if memory serves. Your spring meeting this year, which takes place in May, is in Taiwan. Is that unusual?
No. Before COVID, HDP was doing one in North America, one in Asia, and when we had a lot of members in Europe, one in Europe. Now we're doing the annual meeting in February in North America, a spring meeting in May or June in Asia, and then a virtual meeting in the fall, October. So last year we had our spring meeting in June in Omiya, Japan. That was hosted by Mitsui Gintoku. This year we will have our spring meeting in Taipei. It will be hosted by Cotec Development. Our February meeting this year was hosted by Juniper in Sunnyvale, and last year it was Keysight in Santa Rosa. So our members basically host the meetings. We had a good time in February. So.
Yeah, a good time. Well, good to hear. It does sound like you have a busy time as well. I will remind listeners that the podcast has been brought to you by PCB East, the Electronic Industries East Coast Conference and Trade Show, and the Ultra HDI Forum coming in June to Boston. Learn more at pcbeast.com. And listeners who want more information on HDP can visit hdpusergroup.org. Madan, it sounds like you have a busy year ahead, as always. It's always a pleasure to have you on the show. I hope you come back anytime and keep us updated.
Well, when I have something to update you on, Mike, I'll be happy to be back. Thanks for having a chat today. It's always a pleasure.
This is Mike Buteau for PCB Chat. Have a good day.